Okay, I'm having a little crisis in confidence here. I've got this. I don't see anything wrong with the derivation, but of course I'm capable of messing things up, writing something down wrong, little clerical errors and so forth. I don't think there's a conceptual error here. Let me explain what I'm a little queasy about. Okay, I want to get the energy per unit area. Well, the energy per unit area here is just going to be, per unit volume, I'm sorry, energy per unit volume. So the energy is this. The volume is just the area of a plate times delta x. Okay, it's very straightforward. So the volume between the plates is A delta x. So the field energy per unit volume that I was about to write out would be this expression divided by A delta x. Now what was bothering me was that, well, delta x's divide out as I think they probably should, but the area doesn't. I get an area squared in the denominator. So that was that's bothering me a little bit, but all of a sudden I see that I've got q squared over a squared, and what's q over a? Q over a is just the charge density on the plate, so this is just the square of the charge density. So I'm feeling a little better about it. Now I'm gonna actually stop and do something I rarely do. I'm gonna take a look at the textbook and see what their result is. I think they've probably done this from a somewhat different point of view. Okay, I've looked at the textbook, and what they get is equivalent to 1/2 c squared, 1/2 c v squared divided by a delta x. Now they use b for the distance between the plates. I use delta x, but just replacing their b with delta x, I get this, and I can reconcile that because here's the capacitance. The capacitance involves an A in the numerator, and the voltage is going to be this. If I square this, it'll involve a squared A in the denominator. And if I work all that out, my 2 pi k q delta x over A, this 2 pi k q delta x over A without the q is just my voltage. Okay? Then and actually I have this wrong. I put C here. I believe that's QV squared, because now what I have is okay, I'm getting a little confused here because I'm looking at things and don't have them all written out. And I don't mind you seeing that. You have to think the same way. You have to reconcile everything. So I don't mind demonstrating me doing the same thing. So my leftover q here is my q. I don't think I have a v squared. I've got a v here. But it's a 1/2 v because I've only got 2 pi here where I've got 4 pi. So I get 1/2 qv, and then I'm going to divide that. Okay, so this is 1/2 qv here. So I can say that's 1/2 qv. Here's my v. If I multiply this by 1/2 q, I get this. And then I'm dividing by the volume A delta x. And this does reconcile, so I think I'm correct here. So we're going to move on. Okay, with some confidence now that this is a correct expression, we're going to divide this energy, which is, we're going to call the field energy. That's the energy you can think of as stored in the field here, per unit volume. So we just divide the expression for the energy by the expression for the volume. And that's going to be 2 pi k q squared over a squared. Because when we divide this by a delta x, we're going to have an a squared in the denominator, but the delta x is going to go away. there's our expression. Now, also noting what I realized as I was thinking about this, that Q squared over A squared is the square of your energy density, or your charge density, your charge per unit area, sigma. So we got 2 pi k sigma squared. And if you then look at this expression a little differently, compare it with our expression for V and our expression for Q, that is going to be 1/2 QV, which is what we have here, divided by A delta X. I'm going to go back and look once more at the book's expression to make sure we're completely reconciled, because I thought there was a square in here somewhere, but it doesn't appear there should be, unless I've just made another mental error here. Okay, I remembered the square, but there was a little thing going on here. Instead of Q, instead of QV, they use CV squared. But since Q is equal to CV, that's equal then to 1/2 CV times V, 1/2 CV squared over A delta X. This is the expression in your text, and it reconciles perfectly with everything else here.